Okay guys, vodcasting the solutions to the UDO. Hopefully on this first problem you identified that you were given the volume and you were given two different gram values for different gases. So it was a mixed gas problem and you were given the temperature and the volume. And we were not given mole values. So hopefully you realize that we're going to use equation 2a. Now we know that the version of equation 2a that I talked about said that P total is equal to the sum of the mole values. So in this case we have methane, which is CH4, plus carbon dioxide, which is CO2, times R times T divided by V. So we're going to go over here and we're going to convert the 4 grams of CH4 to moles of CH4. Carbon's 12, that's 4, so that's 16 grams for every 1 mole of CH4. And we're going to do the same thing with the CO2. 10 grams of the CO2. There are 44 grams for every 1 mole. And 4 divided by 16, that's going to be 1/4. So this is going to be 0.25 moles here. And get out my iTouch calculator. 44 equals 0.23 moles here. Alright. So I'm going to plug this in. I'm going to add both of these up. So this should be 0.48 moles. There's your total moles. And P total would be equal to 0.48 multiplied by 0.0821 multiplied by the temperature, 0 degrees Celsius plus 273 equals 273 Kelvin. And we are going to divide that by the overall volume, which is 2.5. So I'm going to do that. 0.48 times 0.0821 times 273 equals that. Divided by 2.5 equals 4.3. So overall pressure is 4.3 atmospheres. Let's go on to the next problem. Okay, in this case we have a sealed container. Okay, it's a mixed gas problem because we have CO2 and we have carbon monoxide here. So it is a mixed gas. 2 gases in a sealed container. Okay, we're given the temperature, so if we're given the volume we could use this equation here. But this one's actually easier. We're not given the volume. We are given just individual moles. So in this case, we're going to go for equation 2b. And it's asking for the partial pressure of CO. Most of the time, folks, in equation 2b, what they're asking for is the partial pressure of one of the individual gases. So this is going to be moles of CO divided by total moles multiplied. Ooh, I'm going to make my little parentheses here. Multiplied by the total pressure. A little side point that I'm going to put in here. We'll do it in purple. Right here. In this equation, this P total, since all you're doing is multiplying the pressure by the fraction of moles, okay, since you're not using PV equals nRT here, this can be in atmosphere, it can be in torr, it can be in millimeters of mercury, it can be in PSI, it can be in really any unit. You'll see in this problem that it's actually in torr. So you can go ahead and convert to atmospheres if you want. Okay, if you wanted to convert this, there are 760 torr in every 1 ATM. But notice the problem asked, well, it just asked for the partial pressure. So if you don't change it from 700, your answer is going to come out in torr. If you do change it from 700, it's going to come out in atmospheres. Let's not change it since I did not give you this conversion factor in this problem. So we have 1.5 moles of CO. Total moles is 3.0. moles. And we're going to multiply that by 700 torr. Okay, notice this ends up being 0.5. 700 divided by 2 is going to be 350. If you wanted to convert that to ATM, you could do it by dividing it by 760. And you guys can go ahead and do that. I'm not sure what it would be. So to recall here, in this problem, both of these are mixed gases. In 2A, we're going to use the expanded PV equals nRT equation. Since we were given T and we were given V, we converted both grams to moles, added them up, and stuck them in the equation. In this problem, it's a mixed gas problem as well, but since we were given moles and we were already given actually the total pressure of 700 torr, multiplying that by the mole fraction of carbon monoxide gives us the partial pressure due to carbon monoxide. All right, guys, take care. Bye-bye.